Good morning. Let's get started with the lecture for today. So we are gonna go ahead and continue talking about sequence and series and talk about another topic today. So sequence and series. So a sequence is defined as a function on natural numbers. So natural numbers are 1, 2, 3, etc. So you define a function f from natural number to, let's say, real numbers. Normally, what we do, the notation we follow, we write this thing as 1 being mapped to f of 1, okay? 2 being mapped to f of 2, 3 being mapped to f of 3, and we label them as A1, A2, A3, and so on and so forth. And the sequence is written as A1, comma, A2, comma, A3, comma, dot, dot, dot. So this is this is the definition of sequence. It maps the natural number to a real number. Okay. Now let's go ahead and talk a little bit more about sequence. There are two types of sequences that we talked about: arithmetic sequence and geometric sequence. So arithmetic sequence is this. So let's say you have your first element in the sequence is A. A1 is equal to A. Then the second one is going to be A2 is equal to A plus some difference D. Your third element is going to be A plus 2D. That means you're increasing the difference every time. A4 is equal to A plus 3D. And you can go on like this. AN is equal to A plus n minus 1 times D. All right. AN is equal to A plus n minus. So note, this goes to n minus 1. And here the subscript is n. Okay. So that's what AN is. All right. You increase by a fixed number. Increase the sequence, each entry in the sequence by a fixed number. Okay. Or you could decrease this D could be negative too. Now we are going to talk about partial sum of arithmetic sequence. Partial sum of arithmetic sequence. What is partial sum? Partial sum is basically, as the name implies, it's sum of part of the sequence. Partial sum is sum of part of the sequence and is denoted by S sub n. So remember, S sub n, partial sum, is A1 plus A2 plus A3 plus dot 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 plus AN. A1 plus A2 plus A3 plus dot 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 plus AN. You are adding the first n items. That's what it means. Okay. So we are going to go ahead and find partial sum. And then infinite sum, which we also call series, okay, infinite sum. So if this n approaches infinity, this subscript n approaches infinity, so that means that this sequence gets bigger and bigger and bigger and bigger. So when you're considering a sequence, it's an infinite sequence, okay? So as n approaches infinity, S sub n, okay, S sub n becomes S, okay? S sub n becomes S. That's the notation we use, infinite sum. You can think of it that way, infinite sum. So S would be, S sub n would be summation I is equal to 1 to n A sub I. That means if you expand it out, what is it gonna be? This is the same as saying A1 plus A2 plus A3 plus dot 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 plus an, right? That's what it means. These and these are the same thing, okay? This is just a compact notation, and this is just a written out version, okay? So this is what A sub n, S sub n mean. Okay, remember once again, S sub n is sum of the first n elements, and this is how normally we write. I is equal to 1 to n A sub I. When I is 1, you get A1. When I is 2, you get A2. I is 3, you get A3. You add them up all the way up to when I is n, you get A sub n. However, if you get infinite sum, then it becomes S, okay? Or we call it series, is summation I is equal to 1 to infinity, okay? It goes to infinity, A sub I. In that case, this becomes basically A1 plus A2 plus A3 plus dot, dot, dot. It keeps going forever. So that's your series, and this is the partial sum, which is finite sum. So difference between this series and the partial sum is that this is finite, sum of finite terms, and this is sum of infinite terms. Now, there are situations where this will diverge. That means it does not converge to a value, okay? This will diverge. And there are situations where this infinite sum or series will converge. There are situations where it converges, and there are situations where it diverges. Next, how do you find out how do you find the partial sum? So here I kind of want to give my famous example that I gave you as well before. When Gauss, C.F. Gauss, he was a little kid, his teacher asked him to add 1 through 100, thinking that it would take him long time, take the class long time, right? To do this addition back in those days. They didn't have calculators. So, but he did it very quickly. So the way he did it is kind of the logic that I showed you. So you add 1, 2, you want to add these numbers, right? 1, 2, 3, 4, 5, 98, 99, and 100, right? Now this is all you need to add, all of them. So let's call this S, okay? Sum of these numbers S, okay? And then also note, is the same thing as saying 100, 99, 98, 90, sorry, 199, 98, 97, 96, and you keep going, 3, 2, 1. If you add these two numbers, you're gonna get S plus S is 2S, right? Is equal to 100 plus 1 is 101. 2 plus 99 is 101. 3 plus 98 is 101. 4 plus 97 is 101. 5 plus 96 is 101. 98 plus 3 is 101. 99 plus 2 is 101. 100 plus 1 is 101. So look, this is gonna be 100 of them, right? Times 101. That's what it is. Now you can divide both sides by 2. That's going to give you on the left the sum, and on the right 50 here. Okay, so 50 times 101. And if you multiply it, I think it's 50, 50. Okay. So this is how it was done. So sum of the first 100 numbers is 50-50. However, we can apply the same logic in finding the partial sum. So let's say my S sub n, okay? S sub n is equal to, look at this, A1, which is A, right? A1 is A, plus A2 is A plus D, A plus D, A3 is A plus 2D, and I don't have to write it all, plus the last term is A plus n minus 1 times D, partial sum. So all I have done is written out all the things. So that's basically writing this out, partial sum. Okay, it's basically writing this out. But instead of writing A1, A1, A2, A3, and AN, what I did, I actually wrote down the terms A plus D, A plus 2D, A plus 3D, and so on and so forth. Now I'm going to write down Sn, again, the same thing in reverse order. So in the reverse order is going to be A plus n minus 1 times D, right? Okay. Then A plus n minus 2 times D plus dot 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 plus, okay, A, the last term. Now if I add these two, look what I get. 2 times Sn, 2 times Sn, okay? 2 times the partial sum. Now look, this is gonna be A, so this is gonna be A plus A times n minus 1 times D. So I'm adding this and this. So look at this, I'm gonna put it in square bracket so that you can see it. And the next one is gonna be, if you simplify it, next one is this one. If you simplify it, it's gonna be, so I'm gonna do it on the side so that you can see it. It'll help you see things. So the next one is gonna be A plus D, remember, which is this term. A plus D is gonna be added to this number. A plus D plus A plus n minus 2 times D. All right. A plus D plus A plus n minus 2D. So look, I can rewrite it as A plus D plus ND minus 2D. Okay, D times N is ND, D times negative 2 is negative 2D. If you simplify it, you're gonna see this becomes A plus ND, D take away 2D is negative D. So if you simplify it, it becomes A plus n minus 1, I factor out D times D. So this becomes, look, then this becomes nothing but exactly the same thing as this. A plus A times n minus 1 times D. Okay, I just simplified part of it. Okay, so I think I forgot to write an extra A here. So there is A plus D, and then there is this A. That's why there is a little bit. So there is another A. Okay, so this should be another A. So if you simplify it, if you basically add this with this, you're gonna get exactly the same thing that you did here. So this, and you can do it, and the very last term is gonna be, it's kind of like getting 101 every time. Okay, if you add this number and this number, you get 101. So A plus A times n minus 1 times D. And how many of them do you have? N of them. Okay, so you have n of them. So I'm gonna just use a different color so that you can see it. So you'll have 2 S sub n is equal to n times A plus, okay? Let me see if I can erase some of it. Okay, so I'll use this space. 2Sn is equal to n times A plus A times n minus 1. Sorry, A plus A plus. Sorry, I made a slight mistake here. This is a plus, my bad. I did it here, right here. A plus n minus 1 times d. N minus 1 times d. Okay. If you do that, you're going to get 2 times Sn is equal to n times. Now look, this is your first term A1. Okay, A1. And this is your last term An. So this is in essence A1, okay, or A1 is A in our case, right? A plus A sub n. And if you divide both sides by 2, you get S sub n is equal to n times A plus A sub n over 2. And this is the formula for partial sum, okay? For arithmetic sequence, this is the formula for partial sum. So I just showed you the derivation just to make sure that you get a sense of it. If you are not 100% sure how I got this derivation, all of this, just think of this. This is easy. You write 1 to 100 in one order, and in reverse order 100 to 1, and you add them, you get 101. How many pairs? How many 101s you have? You have 100 101s, right? Right here, 100 101s. Exactly the same logic. S sub n, the partial sum from here to here. If you write the partial sum in reverse order and you add them and simplify them, you get this. So this is what the formula is. Now you can use this formula. So let me clean it up and write down the formula. Partial sum for arithmetic sequence is S sub n is equal to n over 2 times A plus A sub n. Remember, A is the first item, okay? Now that we did this, you can go ahead and solve some problems, okay? So let's say I give you this sequence. Let's consider a sequence. 10, okay? 7, 4, 1, -2, -5, -8, and so on and so forth. That's your sequence. I would like you to find the S sub, let's say, 101. What is the sum of the first 101 terms in this sequence? Okay, you can find it, use the formula. So your n here is n is equal to 101. That means you want to find the sum of the first 101 terms. Now, what is your A? A is the first term in the sequence, or A1, which is 10. Okay. What is A sub n? Remember, A sub n is A plus n minus 1 times the difference. Okay. So here, the A is 10, right? We found it. This A is 10 plus n minus 1. N is 101, right? Minus 1 times the difference. So what is the difference? So you go from 10 to 7, 7 to 4, 4 to 1, 1 to -2. So the difference is 3, right? Okay. D is -3. All right. So D is -3. So you put -3 here. If you simplify it, what do you get? So it's going to be 10 plus 101 minus 1 is 100 times -3, right? So that's going to give you A sub n, A sub 101, right? Okay. A sub 101 in our case is going to be 10 minus 300 is equal to -290. Okay, it's -290. So use the formula now. S sub 101 is equal to n 101 divided by 2 times A is 10 plus -290. If you simplify it, 101 divided by 2, 10 minus 290 is 280, negative, right? -280. 2 goes into this 140 times, right? So it's going to be 101 times -140. So 101 times -140 is going to give you -14140. That's your answer. So sum of the first 100 terms is, by the way, -14,140. Is this clear to everybody?
I probably will need to keep watching this video.
What is it?
I'll probably need to rewatch this video to like, I don't know, keep refreshing my head on it. It's a lot.
Which part do you think you need help on? Which part you didn't follow? Again, I'm happy to go over that.
I don't know. It's just pretty hard to. It's just weird for me to understand it.
It's a bit more mathematical.
Yeah, it's just something very. I don't know. I mean, like the sequence thing and everything seems simple to grasp and everything, but it's just different, I guess.
Okay. Okay. How about this? Would you want me to do another example of this type?
Yeah, that'd be probably good.
Okay, good. Let's do another example. So let's say I give you another sequence, something like that, 5, 1, -3, -7, -11, -14. First, find out what is A. A is the first term in the sequence, which is 5. And D is -3. How do you find D? Take the second term and subtract the first term from that. Or take any two consecutive terms, subtract the first term from the second term. So I take 7, -7, and -3. So -7, that's the later term. From that, you subtract -3. Okay, is equal to -4, right? Oh, sorry, this is not -3, it's actually -4. -4. So your D is -4. So that means, so did I made a slight mistake here. This should be -15, sorry. So D is -4. Okay, difference is -4, meaning that it goes down by 4. So from 5, it goes to 1. From there, it goes to -3, -7, -11, -15, and the next one is going to be -19 if you want to write down, and it keeps going. So let's say I want you to find, again, find S sub 101. That means sum of the first 101 terms. Okay, sum of the first, let's make it even 100 this time. Sum of the first 100 terms. Okay, so which is technically is going to be A1 plus A2 plus ... plus A100. If you write it in summation notation, it's going to be I is equal to 1 to 100 A sub I. This is the compact notation. This is the expanded notation. Now, we know that S sub n is equal to n divided by 2 times, okay, n divided by 2 times A plus A sub n. That's it. We know A is 5. What is A sub n? Remember, A sub n is equal to A plus n minus 1 times D. A sub n is A plus n minus 1 times D. What is A? A is 5 plus n is 100, right? Minus 1, okay? N minus 1. And the difference is what? Negative 4. D is negative 4. So if you simplify it, what is it going to be? A sub n or A sub 100, okay? I'm going to write the actual notation. A sub 100 is going to be 5 plus 100 minus 1 is 99, right? 99 times negative 4 is going to be 5 plus 99 times 4 is 396. So it's going to be actually negative, right? Because 99 times negative 4 is going to be negative number. It's going to be negative 396. So if you simplify it, it's going to be negative 391. So your A sub 100 is equal to negative 391. Now you just take these values and plug it in here. So S sub 100 is equal to N is 100, right? Divided by 2 times A is 5 plus AN is negative 391, right? So 2 goes into 150 times. So your S sub 100 is equal to 50 times negative 386. So 386 times 50 is equal to 19,300 negative. So your answer is negative 19,300. Michael, does it make you feel a little bit more comfortable with this?
Yeah, that actually helped to get enough. Just I don't know. I just usually seeing it and writing it again just helps a lot.
Okay. All right. Now let's talk about something else. Okay. Similar, another example I'll give you. If I gave you a sequence in which, let's say, A sub 10, okay? A sub 10, I'm making it on the fly, so let's see. Let me see if I can find an example somewhere. I made an example. Okay. For geometric, I have it for, okay. So for an arithmetic sequence, given A sub 2, remember it's for arithmetic sequence. For an arithmetic sequence, you're given a sub 2 is equal to 8 and a sub 9 is equal to negative 41. Okay. A sub 2 is 9. A sub 2 is 8 and a sub 9 is negative 41. And I want you to find a sub 101. A sub 101 is equal to what? You need to find that. The way to find it is this. Remember, a sub 2 is actually a plus d, right? And a sub 9 is a plus 9 minus 1 times d, which is a plus 8d. Okay, so this is your a sub 2, which is 8, right? This is your a sub 9, which is negative 41. So you can have two equations. So a plus d is equal to 8 and a plus 8d is equal to negative 41. Negative 41. Now you can solve it. Just subtract one from the other. If you subtract, a minus a is 0, b minus 8d is negative 7d, right? 8 minus minus 41, right? Negative 7d is equal to 8 plus 41 is 49. If you divide both sides by negative 7, that's going to give you d is equal to negative 7. D is negative 7. All right. D is negative 7. All right. If D is negative 7, then we need to find A. It's easy. A plus D is equal to 8, right? A plus D is equal to 8. A, D is negative 7 is equal to 8, or A is equal to 15. So you found A. Now, how do you find A sub 101? Then easy. A sub 101 is going to be A plus 101 minus 1 times D. And you have all of these. A is 15, right? A is 15 plus 101 minus 1 is 100 times D is negative 7 is going to be 15 minus 700, which is negative 685. There you go. Pretty easy, pretty straightforward. Any question, anybody, so far? Anyone?
It seems pretty good to me.
Okay. So let's go ahead and jump into geometric sequence. We talked about it last time, arithmetic sequence and geometric sequence. So I'm kind of repeating it to make sure that you guys feel comfortable with it. Geometric sequence. Geometric sequence has the following term. So it has something called the first term, A. So A1 is equal to A. This A is some number. And after that, you have something called R, which is ratio. Okay, so you're going to get A2 by taking A1 and multiplying it by R. You're going to get A3 by taking A2 and multiply. A2 is this, multiplied by R, right? That's going to give you A R square. A4 is going to be, take the last term, A R square multiplied by R, which is A R cube. A5 is equal to, take the last term, AR cube multiplied by R, which is AR to the power 4. And you get the idea. A6 is going to be, if you simplify it, AR to the power 5. A7 is going to be AR to the power 6. And if you do it, A sub n is going to be AR to the power n minus 1. Note, n minus 1. One less. And if you take the ratio of two consecutive numbers in the sequence, in this geometric sequence, so in this case, our sequence is AR square, AR cube, AR to the power 4, and it keeps going. Note, so here is a note. Okay. Take these two numbers, doesn't matter, or these two numbers. Let's take the AR to the power 4, this term, and divide it by the previous term, AR cube. You're going to get A cancel out, R to the power 4 over R cube is just R. Or you take this term and this term, so let's say AR cube divided by AR square, which is also R. Or you can take this to AR divided by A is equal to R. So that means if you divide two consecutive terms, divide the later term by the earlier term, two consecutive terms, that means one right after another. If you divide the later term by the earlier term, you will get the ratio R, okay? That's like the comparable things in the arithmetic sum is the D. D is fixed from term to term, right? Here, the geometric series, it's sequence, R is fixed. R is called ratio, whereas D here is called the difference, because in arithmetic sum, we're dealing with addition, okay? Addition. And in geometric sequence, we're dealing with multiplication. We're dealing with addition and multiplication. Is this okay, guys? Is this clear?
Yeah.
And I'm gonna go ahead and give some examples. So let's see. Let's get a couple of examples. Let's say 3 over 2, 3 over 4, 3 over 8, 3 over 16, and keeps going. This is a geometric sequence. What is A, the first term? Of course, A1 is equal to A, right? Which is just 3. So your A is 3. What is your R, the ratio? You can take any two consecutive terms. So let's take these two first two, okay? Or you could take third and the fourth, or the fourth and the fifth, doesn't matter. So first two, take the later term, 3 over 2, and divide it by 3. That's going to give you 3 over 2 times 1/3, which is 1/2. R is equal to 1/2. R is 1/2. And you can check it. So let's divide these two here. 3 over 8 divided by 3 over 4. There's going to be 3 over 8 times 4 over 3. 3 cancels out, 4 goes into 8 twice, see 1/2. Or I could take this one and this one, 3 over 16 divided by 3 over 8 is equal to 3 over 16 times 8 over 3. 8 goes into 16 twice, 3 cancel out, that's 1/2. There you go. Do you see? Doesn't matter which two consecutive terms you take, the ratio is always the same. R is always the same. Now, how do I find the partial sum? So you're going to talk about the partial sum for this one, geometric sequence. I showed you partial sum for arithmetic sequence. Now I'm going to show you the partial sum for geometric sequence. Okay. I kind of, kind of in a strange way, I want to do this side by side so that you guys can see it, even though I did the arithmetic sequence once. So let's do it again. Your partial sum for arithmetic sequence is going to be S sub n is equal to a plus d plus a plus 2d, okay, plus dot 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 plus a plus n minus 1 times d. This is a1 plus a2 plus a3 plus dot 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 plus an. Okay, now I'm gonna write down the S sub n again, but in reverse order. It's gonna be a plus n minus 1 times d. Okay, so this goes with that one, so that you know. The next one is gonna be a plus n minus 2 times d. This one goes with this one, plus a plus n minus 3 times d. This one goes with this one, and plus at the last one is gonna be just a. Okay, last time I kind of didn't quite clarify it, so I'm gonna do it again. So I'm gonna go ahead and add these two numbers. It's kind of like, once again, remember, it's like 1, 2, 3, all the way up to 100, right? And writing 100 in reverse order, 100, 99, 98, all the way down to 1. If you add this, you're gonna get 1 plus 100 is 101, right? 2 plus 99 is 101. 3 plus 98 is 101. And how many 101s are there? 50 of them, right? So 50 times 101, which is, by the way, nothing but 50, 50. So 50 times 101 is 50, 50. So some of the, oh, sorry, you have to, what did I do? Okay, it's right. So there are two of them, right? So if you add this up, you're gonna get 100 of them, right? But then you have to divide it by 2. 100 divided by 2 is 50. 50 times 1 is 50, 50. Again, let me just clarify it. This is technically 2 times the sum, because you're adding 1 to 100 with 100 to 1. This 2 times the sum is 100. There are 100, 101. So 100 times 101. You divide it by 2, divided by 2. That gives you S is equal to, this goes into this 50 times, right? 50 times 101, which is 50, 50. Okay. Exact same logic we are using here. This is one of my favorite examples. Okay. This example, it was presented to, I don't know if I told you, there is a famous mathematician. Her name is Miriam Mirzakhani. Unfortunately, this wonderful woman passed away very recently because of breast cancer. She was very young, like 42 or something. And she was from Iran. And her older brother showed her this example of Gauss, how Gauss added 1 to 100 by using this really beautiful technique. And after seeing that, she was like, I don't know, 13, 14, something like that. I think she was in 8th grade at that time, so maybe a little older. After seeing that, she got really fascinated with math, okay? And she started to spend more and more time with mathematics, and she ended up winning the International Math Olympiad. So all over the world, they have math competition for high school kids. It's called International Math Olympiad, and she participated in that, and she was that the top one or one of the top ones. Then she went on to Harvard to study, okay, mathematics. And then after getting her PhD, she moved to Stanford here locally. And she did some significant work that landed her the equivalent of Nobel Prize in mathematics. In mathematics, there is no Nobel Prize, but there is something equivalent. My statement is that it's not equivalent really, it's more prestigious, because Nobel Prize is given to someone who has done significant work, okay, in a field every year, right? So Nobel Prize in physics, right, is given once a year. But no, similar to Nobel Prize is called Fields Medal in mathematics. Fields Medal is given once every 4 years, not once a year, once every 4 years. And there is even more catch to it. You have to be under 40. If you are over 40, they will not give you this award. So this is much more restricted, but people don't know about it as much as the way they do know about the Nobel Prize. So Fields Medal is very prestigious in mathematics. She is the first woman, Miriam Mirzakhani. Miriam Mirzakhani. Mirzakhani. I hope I spell her name properly. Miriam Mirzakhani. She's the first woman ever to win the Fields Medal. Very talented, very, very smart individual. Okay. Unfortunately, she passed away at the age of 42. She used this as her motivation, this example that her brother gave her to kind of get excited. This is an example. I'm so fascinated by it. So simple yet so powerful. Okay, adding 1 to 100. Very simple, but very powerful. It shows the beauty of mathematics and pattern. Okay, how mathematics can have pattern in it, and you can use it to solve problems. All right, back to our problem. So Sn, so I'm gonna add these two. So if I add them to, I'm gonna get 2 Sn's, right? 2 Sn. That's gonna be equal to, again, look, I'm adding, so I'm going to use a different color so that you can see it. I'm adding this one and this one. If you add it and simplify, you're going to see this is A plus n minus 1 times D. That's the first one, okay? Then you add this one and this one. If you simplify it, you will see that this is what it becomes. This becomes A plus n minus 1 times D. And if you keep doing it, the last term will actually be the same. A plus n minus 1 times D. And if you, how many of them are there? N of them, right? Because you go up to A sub n, right? So 2S sub n is equal to n times A plus n minus 1D. A plus n minus 1 times D is actually nothing but A is the first term. This is nothing but A sub n. Remember, A sub n is equal to A plus n minus 1 times D. So this is nothing but A sub n. This A sub n. This is A sub n. So this becomes A plus A sub n. Now, if you divide both sides by 2, you get S sub n is equal to n divided by 2 times A plus A sub n. And that is the formula that we used for addition. I mean, for getting partial sum for arithmetic sequence. Now the geometric sequence, remember, let's do the partial sum for geometric sequence, okay? We're gonna do the partial sum for geometric sequence. So what is the geometric sequence? Remember, S sub n, the partial sum is going to be A plus AR plus AR square plus AR cube plus AR to the power n minus 1, right? Now this goes up to n minus 1. Remember why? In geometric sequence, an is equal to a times r to the power n minus 1. It doesn't go to n. If you go to a times r to the power n, this is actually a n plus 1, the next term. Okay, so that's what it is. Now this is the just writing out. This is what we want to find out. What is this value, this partial sum? Okay, we want to find out this partial sum. Now let's go ahead and do this. Take the same equation, multiply it by r. So I'm going to take it and multiply it by r. So r times s sub n. So then it's going to be ar, okay, plus a r square plus a r cube plus a r to the power 4 and plus plus the last term is going to be, I'm going to write it here, a r to the power n minus 1 times r, right? That is going to be a r to the power n minus 1 plus 1, because r is the same as r to the power 1. So that's going to give you a r to the power n, because negative 1, positive 1 cancel out. A r to the power n. Okay, so now what I'm going to do, I'm going to do something interesting. This is one equation and this is another equation. Subtract one from the other. So I'm going to find s sub n minus r times s sub n. Okay, if I subtract it, look what happens. This minus this, this minus this. So it's going to be a minus ar. Okay, plus ar minus ar square plus ar square minus ar cube. Do you see? So let me use another color to show it to you. A minus this is this minus this. And then this, which is ar, this minus this, ar square. Then this ar square minus this ar cube. And the next one would be ar cube minus ar to the power 4, ar cube minus ar to the power 4. Now, if I keep going this way, the last term is going to be this ar to the power n minus 1 minus ar to the power n. Now look, I could factor out s sub n here. If I factor out s sub n, I'm going to have 1 minus r is equal to, now look, everything cancel out. It's kind of telescopic. This cancel out, this cancel out, this cancel out, this, and the next one is going to cancel out. And everything is going to cancel out except the very last term, okay? And the very first term. So it's going to be a minus a times r to the power n, okay? Now you divide both sides by 1 minus r, divide both sides by 1 minus r, then what you get is this. This and this cancel out. On the left, you have s sub n, right? On the left, you have s sub n, and on the right, if you factor out a from here, you get a times 1 minus r to the power n, all of it divided by 1 minus r. 1 minus r to the power n divided by 1 minus r. See, nice and compact formula. Kind of the same kind of logic that we used, kind of similar type of argument we used. In one case, it's addition. In one case, it's multiplication. So this becomes a very nice formula. This is the partial sum formula for, this is the partial sum formula for geometric sequence. So now you'll be using this formula. Now, what if your n goes to infinity? Okay, as n goes to infinity, S sub n becomes S, the infinite sum. Now, if S becomes the infinite sum, that means n goes towards infinity, for this series to converge, or partial sum to converge rather, it has to be the case that absolute value of R is less than 1. If absolute value of R is less than 1, S converges. On the other hand, if absolute value of R is greater than or equal to 1, S, or the infinite sum, diverges. Okay? S diverges. If absolute value of R is less than 1, then this converges, S converges. If absolute value of R is greater than equal to 1, it diverges. Now, what does it converge to? So now, let me go ahead and make up some space here. Okay. All right. So here is something that I want you to think about. Okay. Think of a number 1/2, okay, to the power n. If n is 1, it's just 1/2. If n is 2, it's 1/4, right? If n is 3, it's 1/8. Do you see that? Because 1/2, n is 1 is 1/2. 1 over 2 square, 1 over 2 cube, right? That's what it is. Next one is going to be 1 over 16, 1 over 32. And you can see that this number, this sequence is converging or going to a number. And that number it approaches is 0. Okay. So here, if R is equal to 1/2, okay, R to the power n approaches 0 as n goes towards infinity. As n goes towards infinity, R to the power n approaches 0. And it's not true for 1/2 only. It could be 1/3. If R is 1/3, you take n. 1/3 to the power 1 is 1/3. 1/3 to the power 2 is 1 over 9. 1/3 to the power 3 is 1 over 27, right? 1/3 to the power 4 is 1 over 81. And you can see this number is getting smaller and smaller and smaller. And as n approaches infinity, 1/3 to the power n approaches 0. As a matter of fact, it's not only for 1/3 or 1/2. Any number for which R for which the absolute value is less than 1, R to the power n is going to approach 0 as n approaches infinity. R to the power n is going to approach 0 as n approaches infinity. That's what we are going to talk about here. Your S sub n is equal to A times 1 minus R to the power n over 1 minus R. Now, as n goes to infinity, R to the power n goes to 0 if absolute value of R is less than 1. So in that case, this partial sum becomes the regular series or regular sum of infinitely many terms, then this term becomes 0, right? So this term becomes 0. Then you have a times 1, a over 1 minus r. If a geometric series converges, okay, if a geometric series converges, it will converge to this value. Nice and pretty. A over 1 minus r. Why? R to the power n approaches 0 or becomes 0 in the limiting case as n approaches infinity when r absolute value of it is less than 1. The absolute value of this is less than 1. Is this clear to everybody? Okay, let's do an example. The example is this. Let's say I gave you this sequence. This is a geometric sequence. 3, 1, 1/3, 1/9, 1 over 27. And it keeps going. And your first term, A, is equal to 3, okay? And your R, by the way, is gonna be 1 divided by 3. You can check it with another one, R. Let's say R is equal to 1 over 27 divided by 1 over 9. You can check it is 1/3. So your A is 3, R is 1/3. So I'd like you to find S sub n is equal to A times 1 minus R to the power n divided by 1 minus R. I want you to find partial sum. So let's say I want to find the partial sum for S sub 10, okay? S sub 10. So it's gonna be A is 3, right? So I'm gonna put 3 times 1 minus R is 1/3. So it's gonna be 1/3 to the power 10, okay? Divided by 1 minus 1/3. So if I simplify it, it's going to be 3 times 1 minus 1 over 3 to the power 10. 3 times 1 minus 1 over 3 to the power 10. This is what it is. All of it divided by 1 minus 1/3 is 2/3, right? So it's going to be 3 times 3 over 2 times 1 minus 1 over 10, 3 to the power 10. And this number, by the way, is very small. 1 divided by 1 over 3 to the power 10 is very small. So the number you get from here is going to be 0.9999, bunch of things, okay? So you have to multiply it by 9. 3 times 3 is 9 divided by 2 is 4.5, right? So it's going to be 4.5 times 0.9 something. Your calculator will give it to you. And when you're doing these kind of numbers, you want to round it to the 100th place. That's normally what I do, okay? Just round it to the 100th place because we are not looking for accuracy at the higher digits, at the higher decimals, okay? Just 100th place, which is the second digit after the decimal. So this is how you will find it. Now, another example I kind of want to touch on here is this. So let's see if I can find anything here. Something nicer. Let's use this as an example, okay? Next term is going to be 1 over 81, and this. Now, let's see. I tell you, so this is A1, A2, A3, A4, A5, A6, okay? I tell you, A6 for a geometric sequence is 1 over 81, and A2 is 1, okay? A6 is 1 over 81, A2 is 1, and I want you to find, let's say, A7 or something. find A7. What is it? Easy. Remember, A sub 6 is A times R to the power 6 minus 1, 5. And A2 is A times R to the power 2 minus 1, just R. So you can do A6 divided by A2 is equal to A times R to the power 5 over AR, right? So now A cancel out, R to the power 5 over R is R to the power 4, right? So that's A6 divided by A2, which is the same as 1 over 81 divided by 1, right? Because A6 divided by A2 is R to the power 4. So that means 1 over 81 divided by 1, which is the same as R to the power 4 is equal to 1 over 81. And if you take the fourth root of it, you'll see that R to the power 4 is equal to 1 over 3 to the power 4, okay? Or 1 over 3 to the power 4. So R must be 1/3. You just found the R. Now that you found R, you can find A easily. A2 is equal to A times R, which is just 1, right? A2 is 1 given to you. But R is 1/3. So A times 1/3 is equal to 1, or A is equal to 3. So do you see? A is equal to 3. A is equal to 3, and R is equal to 1/3. A is equal to, A is equal to 3, and R is 1/3. Now, if you want to find A7, A7 is going to be A times R to the power 7 minus 1, 6. So it's going to be A is 3 times R is 1/3 to the power 7 minus 1 is 6, right? 6, which is the same as 3 times 1 over 3 to the power 6, which is the same as 1 over 3 to the power 5. So 1 over 3 to the power 5. What is 1 over 3 to the power 5? So 3 to the power 5 is 243. So seventh, the next item is going to be 1 over 243. So if you know any two terms in a geometric sequence, okay, you can find any other term because you know the ratio and you know the first term. If you can find out A and you can find out R, then you can find any term in a geometric sequence. Like the way in arithmetic sequence, you can find out A and you can find out D, you can find out any sequence, any element in the sequence. And one last example here is this. If, let's see, infinite. So if I have a sequence, let's say 1, 1/3, to make it simple, 1, 1/2, 1/4, 1/8, okay, 1/16, 1/32, and so on and so forth. So if I want to find the infinite sum, 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, right? Plus dot dot dot. If I want to find this infinite sum, that's easy. Your A is 1, right? A is 1, the first term. And your R is 1/2, you can see it. So your infinite sum is going to be S is equal to A over 1 minus R. A is 1, 1 minus 1/2, R is 1/2 is equal to 1 over 1/2 is equal to 2. So sum of this, infinite sum of this series is actually 2. Or I could do the similar thing, 1, 1/3, 1/9, okay, 1/27, 1/81, and 1 over 243, and so on and so forth. So if I want to find the sum, S is equal to 1 plus 1/3 plus 1/9 plus 1/27 plus, I'm writing a bunch of terms, but 243 and keeps going forever, right? So it's simple. A is equal to 1 and R is equal to 1/3, right? So S is A over 1 minus R. A is 1 divided by 1 minus 1/3, which is 1/2/3, right? Which is 3/2. That is 1.5. You can see that. So this is all I wanted to talk about. Arithmetic sequence, geometric sequence, partial sum, total sum or series, infinite sum. And there will be a homework on this, and I'll be asking some questions on the midterm. I mean, in the final. Any question, anybody, about this? Okay. So now let's go ahead and do another example that I kind of wanted to do. This is about finding inverses of a matrix, okay? We did talk about find inverse of a matrix. We are going to do it for 2 by 2 matrix, 2 by 2, simple. If you have a matrix A, let's say, is, no, actually, let's use M. That's, if you have a matrix M, A, B, C, D, okay? You want to find the inverse of this matrix. Let's call it M inverse, that's the notation. Inverse of this matrix is nothing but 1 over determinant of M, this one, right? Times D, negative B, negative C, and A. Remember this A, B, C, D. D, negative B, negative C, and A. So you switch the A and D, okay? And then put negative sign in front of B and in front of C. That's what it is. Now, let's go ahead. Let's go ahead and find determinant of a matrix. So let's say, I mean, inverse of a matrix. Now, the thing about matrices, if two matrices A and B, let's say two matrices A and B, they are inverses of each other, okay? Then A times B is the identity matrix. It's a square matrix, remember. This is a square matrix we are talking about, okay? So the inverse of A is B, then A times B is identity matrix. And B times A is also identity matrix. That means AB is the same as BA is the same as identity matrix, okay? It doesn't matter which way you multiply these two matrices, you always get identity matrix, okay? How do you know a matrix has an inverse? There is a way to check it. So let's say I give you this matrix. How do I know that it has an inverse? All you have to do is find the determinant of it. So the determinant of it is -3 minus 8 is -11. If the determinant is not equal to 0, then the matrix has inverse, and we call it invertible. If a matrix has inverse, we call it invertible matrix. So anytime I give you a matrix, you want to find out whether it has an inverse, you just take the determinant of the matrix. 2 by 2 matrix, you know how to do determinant, right? If the determinant is not equal to 0, then it has inverse. So in general, if the determinant of a matrix is not equal to 0, then matrix A has inverse. If the determinant of a matrix is not equal to 0, then matrix A has inverse. It's a rule that you should know. Now let's find the inverse of these guys. So determinant is -1, right? So we are going to just use this formula. So it's going to be 1 over -11, I meant 1 over -11 times A and D switches, right? Here, A, B, C, D, A, B, C, D. So A, D and A are going to switch, is going to be 1 and -3, and B is going to be -2, C is going to be -4. What I did, I converted this into this format. D and A, D is 1, A is -3. So I switched D and A. So now this is D. So now it has the same structure as 1 over determinant of the matrix A times D, -B, -C, and A. I just did that. Now, this is it. That's done. So that's your inverse, M inverse, or A inverse, whatever you call. So let's call this M. So let's find M times M inverse. Okay, M times M inverse. So what I'm gonna do, I'm gonna take this -1 over 11 in the front. Okay. Then I'm gonna multiply this matrix with this matrix. Because remember, for a matrix, A, some constant A times a matrix is the same as multiplying A times Mn, two matrices, let's say, is the same as A times M times N, is the same thing. Okay, this is scalar multiplication. So I'm gonna do this 1, -2, -4, -3, and the original matrix -3, 2, 4, and 1. Just multiply them first. -1 over 11, right? So first row, first column. So if I multiply it, I get -3, -8, which is -11. I get -11. First row, second column, I multiply it, I get 0. Second row, first column, I do the dot product, I get 0. Second row, second column, I do the dot product, I get, what is it I get? 4, -4 times 8 is -8, -3 times 1 is -3, so -11. Now, if you multiply these by 1 over 11 negative, right? What you're gonna get is 1, 0, 0, 1. This is the identity matrix. Okay, very, very easy. Very easy. Now you can check it the other way. M inverse M. Okay. Actually, just to clarify, I actually did the other way here. I did M inverse M here. So now here you can do M inverse, M inverse, M inverse. Is gonna be M is gonna be -3, 2, 4, 1. Okay, and then other M inverse is gonna be -1 over 11 times 1, -2, -4, -3. And then I could just bring the -1 over 11 in front because it's a scalar. I could do -3, 2, 4, 1. That's this matrix, and this matrix is going to be 1, -2, -4, -3. And you will see very quickly it's going to be -1 over 11 times. This is going to be -11, 0, 0, -11. And it is going to come down to the same thing, 1, 0, 0, 1, which is the identity matrix. And that is how you find the inverse of a 2 by 2 matrix. Make sure that you know the rule that if the determinant is 0, then the matrix does not have inverse. If the determinant of the matrix is non-zero, then it has inverse. Any question of this? Anybody? Do you want me to do another example of this type? Would it help?
Yes.
Yeah.
Sure. Let's find a matrix A, 2, 3, 1, -2. Okay. I want to find the inverse of it. First, find the determinant of A. What is determinant of A? 2 times -2 is -4, right? Time minus 1 times 3 is -3. 1 times 3 is 3, so it's -7. Not equal to 0. So determinant exists. We know that the determinant exists. Now, how about finding the determinant? This is easy. So it's gonna be, let's say, A inverse is the inverse, right? It's gonna be 1 over determinant of A. Determinant of A times D -B -C A. All right. We found determinant is -7, right? So 1 over -7 times D is going to be -2. C, B is 3, so it's going to become -3. And C is 1, is going to become -1. And A is 2, is going to become 2. That's it. We are done. That is the inverse. Now, you don't want to multiply this 1 over determinant by this. That way it becomes a bit messy calculation. Just leave it this way. Then multiply this matrix with the original matrix and multiply the result by -1 over 7. So if I do A inverse is going to be, I'll bring this thing up front. So it's going to be -1 over 7, okay, times 2, 3, 1, -2, and then this thing is going to be -2, -3, -1, and 2. And then if you do the matrix multiplication, 2 times -2 is -4, plus -3, 3 times -1. So it's going to be, I know it is going to be what it is going to be. It's going to be -7, 0, 0, -7. If you multiply it out, it's going to give you 1, 0, 0, 1. And similarly, you could do it the other way. A inverse A is going to be -1 over 7. Only thing is that this matrix is going to be here and that's going to be there. -2, -3, -1, 2, and then 2, 3, 1, -2. That's going to give you -1 over 7. If you do the math, dot product is going to be -7, 0, 0, -7. And then if you multiply it out, it's going to become the same thing, 1, 0, 0, 1. And that's how you find the determinant of a matrix, 2 by 2 matrix. Now there are ways to find the inverses of two matrices, inverses of a matrix. I mean, inverse of a matrix. If there is an inverse for a matrix, it's a unique inverse. You cannot have two different inverses for a matrix. Okay. There are different ways to find inverses of matrices in higher dimension, 3 by 3. One is the Gauss-Jordan method. So let's say you want to find the inverse of this. I'm not going to show it to you, but I'm going to just give it to you. So let's say this is the matrix A, right? You want to find the inverse of it. So what do you want to do? Let's say you put a vertical line here and you put the identity matrix 1, 0, 0, 1. Now you do the row operations. Remember, we did the row operations, and after you do the row operations, you want to have on the left side the identity matrix 1 0 0 1, and on the right side you will get something, 4 numbers after you do row operations, and this is going to be your inverse matrix. Okay, and you can do it for 2 by 2, you can do it for 3 by 3, 4 by 4, doesn't matter. You do the row operations, and then you start off with the identity matrix on the right. After row operation, you get the identity matrix on the left. And whatever matrix is on the right, that is your inverse of the original matrix. And that is how sometimes people do it. And then there is something else. If you take a course called linear algebra, there is something called cofactor, which is not really hard concept. For matrices of higher dimensions like 3 by 3, 4 by 4, you can use the concept of cofactor and then find the inverse of those matrices. So you can try this out on your own. This is easy. Like if I want to make this look like this, identity matrix on the left, you just have to do row operations. The first row operation, I do it, switch row 1 and row 2. Okay. Why? Because you have a 1 here. So it's going to be 1, -2, 0, and 1, 2, 3, 1, and 0. Right? Then you multiply the first row by -2 and add it to the second row, R2. This becomes your new R2 because look, this is 2. So that's going to make it 0. So you're going to have 1, -2, 0, 1, and 0, and then something else. And you keep doing it until you get to this format, 1, 0, 0, 1. At that point, you stop. And whatever is on the right, that is going to be your inverse. But I showed you a much easier way of doing inverse. So you do that one, determinant, and switch the numbers. Any question, anybody, about this? Now, if I gave you a matrix like 2, -5, 7, let's make it 8, and -20. Okay, I just made it up. Can you find the inverse of this matrix? First of all, you find the determinant. So it's going to be -40 plus 40 is equal to 0. So this one is 0 determinant. So this does not have an inverse. Not all matrices have inverse. But on the other hand, if I give you 1, 2, 3, 4, for this matrix, can you find the inverse? First, find the determinant. Determinant is 4 minus 6 is -2 is not equal to 0. So determinant exists. And then you use the formula, like the one I gave you, this formula. Any question, anybody?
Nope.
Okay, one last topic, and that's gonna be it. Okay, one last topic I wanted to talk about. This is kind of like what we call conic section. Matrices, we talked about it before. Okay, and sequences, we talked about it before. But conic section, here you know it, but I'm gonna still kind of touch on this a little bit. We talked about indirectly about parabolas previously, how to find the vertex of a parabola, intercepts of a parabola, and etc. etc. We are graphing things on the XY plane. Okay, so think of this scenario. Think of this equation: ax squared plus b times xy plus c times y squared, this is uppercase C, plus d times x plus e times y plus some constant f is equal to 0. This is the most general equation for a conic section. Depending on the coefficients a, b, c, d, e, and f, a, b, c, d, e, and f, depending on this, by the way, you're gonna have different things. All right. All right. One of the things that I kind of want to talk about is circle. So we'll talk about it more, a little bit more. So let's say circle. What is the equation of a circle? The equation of a circle has this structure: x minus h whole square plus y minus k whole square is equal to r square. This represents a circle. This represents a circle that has center at h comma k and radius r. This is the equation of a circle. If you break it down, it's going to have this structure with b being 0 and a and c being equal. Okay. This is the equation of a circle. Now, let's go ahead and talk about it a little bit. Let me give you an example. So think of this. So let's see. I created an example. So let's go ahead and do this. Let's see. Okay. Let's say I have this scenario for x square. I'll make it for x square. I'll make it easier. X square plus 4x plus y square minus 6y. What happened? Minus 6y plus 3 is equal to 0. I just made it up. Okay. So let's go ahead and do this. X square plus 4x plus 4. You'll see what I'm doing. Plus y square minus 6y plus 9. So x square plus 4x, with that I added 4. Y square minus 6y, I added 9 to it. So 4 plus 9 is 13. So I subtract 13. And then I have this 3 is equal to 0. It's still the same thing, right? I added 4, added 9. 4 plus 9 is 13. Then I subtracted 13. So net effect is adding 0, right? So that doesn't matter. Plus 3. Now, if you look at it, you probably know this is nothing but x plus 2 whole square. Look, x plus 2 whole square is x plus 2 times x plus 2, right? If you multiply it out, x times x is x square, x times 2 is 2x, 2 times x is 2x, and 2 times 2 is 4. So x square plus 4x plus 4 is x plus 2 whole square. Now, similarly, you can check it. This one is going to give you plus y minus 3 whole square. You can check y minus 3 times y minus 3 is y square minus 6y plus 9. Now, negative 13 minus 3 plus 3 is 10, negative 10, right? I'm going to move the 10 to the right side. Okay. I can do that. So now I took this equation and restructured it in the format of this equation. 10 is the same as square root of 10 whole square, right? Because square root of 10 whole square is just 10. Square root of 10 whole square is just 10. Okay. Square root of 10 whole square is just 10. So now if you compare it with, this x minus h whole square plus y minus k whole square is equal to r square. Can you guys tell me what is h here? What is k here? That will be the center of the circle, right?
Yeah.
What is h in this from this equation?
It's 2, and the other one's -3.
Nope. It's just the opposite. Look, x minus 2 is x plus 2, right? Whole square plus y minus 3 whole square is equal to square root of 10 whole square. So look, x minus h, so h will be -2. H is -2. Y minus k, so this minus and this minus is the same. K is 3. So this is centered at -2, 3. And what is the radius? What is r? Which is easy. Square root of 10. R is square root of 10. Okay. Any questions? Anybody? Let me give you one more example. If I gave you x squared minus 8x plus y squared plus, I don't know, 14y plus 25 is equal to 0. I just made it up. So I could write it as x squared minus 8x plus 16, which is x minus 4 whole square plus y squared plus 14y plus 49. Now, how am I coming up with these numbers? Easy. 8x, you could write it as 2 times 4x, right? So this 4 is going to be squared. 4 squared is 16. 14y is equal to 2 times 7 times y, right? You square that 7, which is 49. That's how I got. Remember, a plus b whole square is equal to a square plus 2ab plus b square. So I added, so 49, 50, 65, okay? So I added 65, I subtract 65, and then plus 25 is equal to 0. So this is going to be x minus 4 whole square plus y plus 7 whole square minus 45. Not, sorry, negative 65 plus 25 is negative 40 is equal to 0. Or I could write it as x minus 4 whole square plus y plus 7. I have to convert it into negative. Y minus 7 whole square is equal to 40 on the right side, square root of 40 whole square. So it's going to be h is equal to 4 and k is equal to negative 7. And r is equal to square root of 40. So your circle has a radius of square root of 40 and centered at 4 comma negative 7. Okay, that's what it is. Any question, anybody?
So I understand how you got most of those numbers, but just out of curiosity, where'd the -65 come from?
Oh, I added 16 and 49. Okay, I added 16 and 49. Okay, so 16 and 49 is 65, right? Did I do it right? Yeah, 65. So I subtracted 65. It's like adding 0, right?
Yeah.
Okay. The last topic for the semester is this. So my equation is going to be ax squared plus b xy plus c y squared plus d dx plus ey plus f is equal to 0. That's what my equation. So here in this equation, b square minus 4ac, that's called discriminant. That's called discriminant. These basically determines what type of things are you going to have. So let me write it down. 1, if b square minus 4ac is equal to 0, okay? Then, 0, then what you get is a parabola. You get a parabola. Okay? If b square minus 4ac is equal to 0, then you get a parabola. Okay, parabola is something we talked about. Number 2, if b square minus 4ac, ac is less than 0, then you get ellipse. An ellipse is something like this. So this is called the center, and there is negative c and positive c. These are called foci. Okay, one focal point or the focal point. I was very amazed by this fact. You take a piece of thread, okay, and kind of connect it here and here, and take a pencil and pull the thread as much as you can, okay, and kind of try to draw a shape, okay, by keeping the length of the keeping the piece of thread in a straight line. As you move, you get the ellipse. Ellipse is actually set of all points for which this distance plus this distance is the same, or this distance plus this distance is the same. So sum of this and this is the same as sum of this and this, or sum of this and this. This sum of these two distances from the foci for ellipse is always the same. Okay, it's constant. So I'll talk about it. And the last one is this: if b square minus 4ac is greater than 0, then what you have is a hyperbola. Okay, so remember this thing. This is the most general form of the conic section equation. Okay, most general form of a conic equation: ax square. It's easy to remember. Ax square plus b times xy plus c times y square plus dx plus ey plus f is equal to 0. Okay. Now, let's go ahead and do an example. Let's see. So we are going to do an example of an ellipse. An ellipse could be, generally speaking, it could be, let me see how good of an ellipse drawer I am. Okay. The center is here, right? There's the center. and the focal points are here and here. Okay, center is H comma K, and the focal points, by the way, let me see, what is my example? Hold on 1 second. Okay. Focal points are, this is gonna be H minus C comma K, okay? And this is gonna be H plus C comma K, H plus C comma K, all right? And vertices, so this one, and there are co-vertices too. This is gonna be H minus A comma K, and then this is gonna be H plus K comma H plus A, not K. H plus A comma K. Okay. H minus A comma K and H plus A comma K. Okay. All right. So let's go ahead and take an example. That way, I will identify different components with that example. That way you will see. And that'll be the last example. So 4x squared plus 16x plus 9y squared minus 54y plus 61 is equal to 0. Okay. 4x squared plus 16x plus 9y squared minus 54y plus 61. So what I could do, I could factor out a 4 here. If I factor out 4, I get x squared plus 4x. If I factor out a 9 there, I get y squared minus 6y plus 61 is equal to 0. Now what I'm going to do, I'm going to do something else. I'm going to make it a perfect square. I'm going to do x squared plus 4x plus 4. So adding a 4 inside the parentheses is like adding 16 because 4 times 4 is 16, right? So I'm going to subtract 16. All right. Plus 9 times y squared minus 6y plus 9. This is going to be a perfect square inside the parentheses. So adding a 9 here is like adding 9 times 9, 81. So I'm going to subtract 81. And then don't forget this plus 61 here. So that is equal to 0. Now you have 4 times this is x plus 2 whole square plus 9 times this is y minus 3 whole square. Now negative 16 minus 81 is what? Negative 91, 7, negative 97. Negative 97 plus 61 is negative 36. Negative 97, 61, 91, 30. Yeah, negative 36. Negative 36 is equal to 0. I could move this negative 36 to the right, and then it becomes positive, right? Now I can divide both sides of this equation by 36. Divided by 36, divided by 36, divided by 36. Okay, so that's going to give me x plus 2 whole square over 9 plus y minus 3 whole square over 4 is equal to 36 divided by 36 is 1. This is the well, I'm going to go one more step. I'm going to write x minus -2 whole square over 3 square. Okay, 9 is 3 square plus y minus 3 whole square divided by 2 square is equal to 1. This is the general structure for a an ellipse, which is x minus h whole square over a square plus y minus k whole square over b square is equal to 1, assuming that a is greater than b. If a is greater than b, it's going to be like this one. If a is less than b, it's going to be like this. Okay? So let's go ahead and work on this. This is the same as, by the way, the other guy. Remember, we had our circle. That was x minus h whole square plus y minus k whole square is equal to r square, with a circle, radius r, and centered at h comma k. Exactly the same way. Here the center is at h comma k. So this is my center. So what is h here? H is equal to -2. What is k here? Which is 3. Look, h is -2, k is 3. So it's going to be located as -2, 3. That's the center. Now, let's say we want to find the focal point here. So we have to subtract h minus c, comma k. What is c? C by c square is equal to a square minus b square. C square is equal to a square minus b square. C is a value which is defined as a square minus b square. So look, a square minus b square, or 9 minus 4 is 9 minus 4 is equal to 5. Okay. So c square is equal to 5, or c is equal to square root of 5, which is approximately, I think, 2.24. 2.24. So now this point is going to be, this point, the left focal point is going to be h minus c. H is -2. -2 minus c is -2.24, comma k. K is 3, which is the same as -4.24, comma 3. Okay. Now let's find this guy, h plus c, right? So h plus c is gonna be, h is -2, right? -2 plus c is 2.24, 2.24, comma k. K is 3, right? That is gonna give you 0.24, comma 3. Very easy. That's how you find that point. Now let's find the next point. So left vertex, okay, and there's another vertex here, another vertex here. These are called co-vertex. This is called just the vertex, the bigger axis. So this is the bigger axis, and then there is the smaller axis, right, for an ellipse. So for this one, h minus a times k. So my h, we found it -2 minus a. A is a square. Remember, a square is the denominator, 3 minus 3, comma k is 3. You just plug in these values. That's it. So it's going to be -5, comma 3. And similarly, you can find this point, which is this h plus a. H is -2 plus 3, comma k 3. So -2 plus 3 is 1, then comma 3. So this point is going to be 1, comma 3. So once you find a and b, so these are the values, you take the equation, convert it into this structure, x minus h whole square over a square, y minus k whole square over b square. If you do that, you can read off hk, which is the center. In our case, h is -2, k is 3. And then c, a and b, you can read it off. Also, a is 3 and b is 2. Whatever is in the denominator, you square it. Then you can find c square is equal to a square minus b square. And then once you have that, from that you can find c. So once you find c, you know a, you know b, you know h, and you know k, you can find all of these values. It may sound a lot of information, but watch the video. You'll get it, okay? Watch the video. I can do another example, but I'll pass, okay? Similar example, or should I do one more? Maybe. I'll just quickly do one on the side, just to give you an idea. Let's say 4x squared minus 16x plus 9y squared plus 18y, let's say minus 11 is equal to 0. And I could write it as 4 times x squared minus 16x plus 16 plus 9 times y squared plus 2y plus 1 minus 11, and then 16 plus, the 64 plus 9. So let's see. Oh, sorry, I made a mistake. That's why I didn't want to do the last example. Okay, so let's go ahead and do it. If I factor out 4, it's going to be x squared minus 4x plus, if I factor out 9, it's going to be y squared plus 2y minus 11 is equal to 0. I could write it as 4 times x squared plus 4x plus 4 plus 9 times y squared plus 2y plus 1. That's like adding 4 times 4, 4 times 4, 16, 9 times 1 is 9. So 16 plus 9 is 25. So I need to subtract 25 and subtract 11 is equal to 0. So this is going to give me 4 times x plus 2 whole square plus 9 times y plus 1 whole square is equal to 36. Then you divide by 36, you're going to get x plus 2 whole square over 9 plus y plus 1 whole square over 4 is equal to 1. Here your h is equal to -2 because you're going to write it as x minus -2 whole square. H is -2 and your k is -1. Your a is 9 is 3 square, a is 3, your b is 4 is 2 square, 2. So you have a, h, k, a, and b. So you can find c square is equal to a square minus b square, which is 9, a square minus b square. So c square is equal to 9 minus 4 is equal to 5, or c square is equal to 5, or c is equal to 2.24 roughly. And I have given you everything here, so you can go ahead and do that. Any question, anybody? It's a bit of information, but it should be not too bad. Watch the video. I'll send it to you today. Watch the video. Let me know if you have any questions, and I'll be putting a couple of homeworks or one big homework, and that's it. And I am gonna put the final exam review as well online, so everything should be ready today. Any question, anybody?
I guess I could just put one.